I'm Anil Kumar. In this video, we will discuss characteristics of polynomial related to its zeros and turning point with the help of few multiple choice questions. So let me first thank my subscribers for sending in this request, and I highly appreciate your active participation on my YouTube channel. Thank you. The question here is, state all possible number of zeros for quartic polynomials. Now quartic means degree 4, right? We are given 4 options to you. You can always pause the video, answer the question, and then look into my suggestion. Now, if we have a quartic polynomial, what are different scenarios? Quartic is degree 4. We'll assume leading coefficient to be positive, right? We are assuming leading coefficient to be greater than 0 in our sketches. Okay, one of the option is that we have a quartic polynomial which could look like this, right? So which could look like this, right? So if it is like this, you can see we have 2 zeros, right? Those becomes a 0, so we have 2 zeros for this particular sketch. If I move this somewhere upwards, kind of, right, we could have a scenario where the polynomial could be kind of like this. You see that? So in this particular case, you observe that there are 3 zeros. And we could actually move it further up, right? Further up, and or we could draw another different one. So let me assume now that, because it's going to mess up a bit, okay, it doesn't matter. Let me sketch one like this here. We could also have one which is like this. Do you see that? In this case, we have 0 number of zeros. Is it okay? We could also have a scenario where the quartic polynomial could be kind of like this. So in this case, an is less than 0, it's negative, right? So in this case, we have one number of 0. Perfect. Now, you could also draw a quartic polynomial which may be kind of having 4 zeros, for example, 4 linear zeros, right, like this. Correct? So we have 4 zeros. So for a quartic polynomial, we could have 0 to 4 number of zeros, correct? Giving you equations for each kind so that it's very clear. If I have x to the power of 4, for example, I have only 1 0, right? If I need, this is 1 0, right? We could have x to the power of 4 plus 1. So number of zeros is 0. This is number of zeros is 1. And if I put it x to the power of 4 of minus 1, we get 2 zeros. But if I could write this in factors like x times x plus 1 times x plus 3 plus x minus 5, that gives me 4 zeros. And to make it 3 zeros, what can I do? I can just get rid of one of these zeros, and I can say x squared times x plus 1 times x plus 3, for example. I get 3 zeros, right? So these are the examples for quartic polynomials with 0, 1, 2, 3, and 4 number of zeros, right? So these are all possible zeros. Let's move on. The next one here is, state all possible turning points for 7-degree polynomial, right? Turning points for 7-degree polynomial. We are again given few options. Take your time, pause the video, answer the question, and then look into my suggestions. Now, let me discuss a few scenarios before we move on. One of them could be a function like this. How many turning points will this have? X to the power of 7. This is a 7-degree polynomial, correct? It has Number of turning points in this case are 0. It doesn't turn, it just keeps on moving ahead, right? This is not a turning point. You get an idea, right? Now, you could have a function which could turn and then reach from, let's say this is quadrant 3 to quadrant 1. A 7-degree polynomial moves diagonally. Perfect. So if I have to move diagonally, let me assume that this is a polynomial and it turns. And after turning, it has to turn again to reach this place. How many turning points do you see in this case? You see that there are 2 turning points. One is here, right there. That's the second one, right? We could write equation of this polynomial. Let's say this is minus 2. We could write this as x plus 2 times turns here x squared, right? So this one has 2 turning points. So we have, let me make a list here. Turning points, we get 0 and then we get 2. Can we have 1 turning point? If it turns once, it has to turn again. So it cannot have 1 turning point, right? So the possible is either 0 or 2. We are looking for degree 7. So this is not degree 7. I'm sorry. This is just a cubic. I made it wrong. I should have gone kind of like this. Let me redo this. I'm sorry for this. Okay, so basically we could have a degree. We need so this is 2, we need 5 here, right? So this is not a turn, it's kind of like this. I should have drawn like this. Is it okay? So make it 5 here. So 5 plus 2 is 7. Is that okay? Yeah, I should have done like this. Perfect. Now, we could have had an example where degree still remains 7, but we could split this into 4 and 1, right? So we could have a polynomial which could, let's say, turn like this, right? This is 5, right? And then go there like this and go like that. Do you see that? Now in this case also we have 2 turning points, correct? We have 2 turning points as you can see. Perfect. But we cannot have 1 or 3 turning points, correct? Now, a 7-degree polynomial could also be sketched by a graph kind of like this. Let me write down the equation first, then it becomes easier to sketch. So we are doing x plus 5, let's say whole square, and then we have x plus 3. We want to make it 7. Let's make it whole square. So we have 2 plus 2, 4. And then we have x to the power of 3. So if you have that kind of a function, then the number of turning points will be minus, this is 0 at minus. Now, since it is leading coefficient with positive, this will be, let me use another ink. So a 0 here, let's say 0 here and 0 there, right? So we have a function which kind of goes here, it turns and then again turns. Is it okay? So number of turning points in this particular case is 1, 2, 3 and 4. Perfect. So we get 4 turning points in this particular case. We get 4 turning points for this particular equation. Now we could have just linear zeros, all linear zeros. In that case I can sketch a function here. So I'm using this space more now. Okay, so let's say we have a function which is 7 zeros. So 1 0, 2 0, 3 0, 4 0, 5 0, 6. So 1, 2, 3, 4, 5, 6. Okay, let's go back this side, 7 zeros. Okay, so that is our function which has 7 zeros, and how many turning points it has? Let's count them. Okay, so the turning points is 1, 2, 3, 4, 5, 6. So there are 6 turning points in this particular case, right? 1, 2, 3, 4, 5, 6. So we get 6 turning points. So you'll notice that for a 7-degree polynomial, we could have 0, 2, 4 or 6 number of turning points. So the option is D, right? It might come as a surprise for you, but all odd degree polynomials will have even number of turning points. They are from 0 to n minus 1. Even numbers. Perfect. Now let's move on to the next question on polynomials. The question here is, state the number of turning points and zeros of the given polynomial. So we have x times x squared minus 3, x plus 5 whole square, x minus 1 whole cube, and that is the combination. I like you to sketch this polynomial to get the answer quickly, right? That'll be great. You could actually count also. Okay, so I hope you got your answer, and here is my solution. Let's find out the turning points without sketching. Okay, can you do that? Try it out. Okay, let's count the degree. So we'll talk about degree first. So degree of this polynomial is 3, 4, 5, 6, 7, and 1, 8. Right? 8 is the degree of the polynomial. Let us also see how many even zeros are there. Degree and even zeros. There's only one even zero, this to the power of 2. That gives you two 1 degree zeros. This order of this 0 is 2. So there's one even 0. So from here, we could actually get the turning points. So turning points you could get from even zeros, and let's call number of zeros. Let's call number of zeros also. Okay, let's go ahead. Number of zeros here are 1, 2, 3, 4, there, and 1, 5. So there are 5 number of zeros. Okay, so we counted number of zeros, even zeros, and the degree. Now let's count what should be the number of turning points. Number of turning points is equal to number of zeros minus 1 plus number of even zeros. I have discussed this in one of my videos. You could always search Anil Kumar polynomial zeros to look for such videos. Now, from the calculation, I mean without sketching, I'm telling you, number of zeros is 5 minus 1, number of even zeros is plus 1. So we get number of turning points as 5. So our answer should be both 5, right? So this one is the answer. Now let's sketch the graph and then check. Okay, so we have zeros at 0. We have 0 at plus minus square root 3, right? So here x equals to plus minus square root 3 to give zeros. So let's say this is minus square root 3, and let's say this is plus square root 3. Then we have 0 at minus 5. Let's say this is minus 5. And at plus 1, so plus 1 somewhere here, let's say plus 1. Since the degree is 8 and leading coefficient is positive, right side up, that's the end behavior, correct? So we'll also review our sketching fundamentals. Degree of only this one is even, which is at minus 5, so it is going to turn here. And then at 1 we have cubic, others are linear. So if I am moving from quadrant 2 to 1, I'll move like this. We are still in quadrant 2, linear 0, adds x linear 0, at 1 cubic, right? So it goes kind of like this. And then square root 3 is linear. Perfect. So joining these, we get a curve, which is kind of like this. You see, we just join them to make a neat graph. Now you can count the zeros as well as turning points. So turning points are 1, 2, 3, 4, and 5. Do you see 5 turning points? That matches. 5 turning points. Zeros 1, 2, 3, 4, and 5. So that is 5 zeros. So that is how from the equation also you can find the number of turning points. And I hope with the help of this set of questions, multiple choice question. You have learned how to figure out number of possible turning points from the given equation of polynomial, and also how to sketch such polynomials. I'm Anil Kumar. Keep sharing my videos and posting questions. Thanks for liking them. Have a great day. Bye.